Let's convert from decimal to binary. Now, when we converted from binary to decimal, we did it by adding numbers from a certain table or a certain chart that looked like this. 1, 2, 4, 8, 16, 32, 64, 128. And we said you could keep going out here, but we're not going to for our purposes. I can represent any number from 0 to 255 with these numbers. Any number from 0 to 255, that is to say any whole number. So let's see how we would convert now from decimal. Again, using this chart. Now what we added using, in order to go from binary to decimal, we're going to subtract to go from decimal to binary. So let's just start with a number. I don't know, I'll just say 27. How would I convert 27? Well, sometimes I call this going to the mall. Because what I want to do is pretend that we're going to the mall and we have a $1 bill and we also have a $2 bill. We did make those at one time, but you don't see them very often anymore. And let's pretend that we had a $4 bill, an $8 bill, a $16 bill, and so on. In other words, we have one of each of these and we can spend those, but we only have one. And by the way, we can't make change. So we can buy anything of any price with one of each of these, up to $2.55. So let's spend, in order to pay $27 to the storekeeper, we would first, well, let me see, I wouldn't give him a $32 bill because remember, we don't get any change. So I'd probably start by giving him a $16 bill. Well, let's subtract out then the 16 that I just gave him. That would be 7 minus 6 is 1. 2 minus 1 is 1. That would leave $11. All right, I might give him an $8 bill. That would be $3 left. Then I might give him a $2 bill. That leaves us with $1 still owing. And I might give him a $1 bill then. And that means there's nothing left. I've paid everything. And so let's just put a 0 because we didn't spend our $4 bill. And so 11011 equals 27. This is the binary. And this one over here is the decimal. All right, that was fun. Let's do another one. Let me just erase these numbers over here. Now I'll erase these numbers over here, and let's do a larger one now. Let's actually do one that would probably put us up, clear up into the past the 128. Right? We know we can't go above 255 with these particular digits. So let's just say 200. All right, let's see what we have to spend in order to make exactly 200. Well, I'd have to give him my 128. So I'll give the storekeeper a 128. Now let's subtract this out. Let's borrow one from there. And it looks like I need to borrow one from here. So now I've got 2 left in this column. I've got 7 left in this column. So I've got 72 left that the storekeeper needs. Well, I'll give the storekeeper a $64 bill then. Once again, I need to borrow one from here to give me 12 minus 4 is 8, and that's all. So I've got 8 now left. So now I'll give him an 8, and now I've got 0 left. So I have now paid the entire thing. Let's put zeros in the slots we didn't use them, because I did not spend any of those. And that means that 110010 I didn't put a 0 here. 0. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So that equals 200. Again, this is the binary over here, and this is the decimal over here. All right, let's do one more. Let's do 192. We'll just X that part out. 192. Well, in order to do 192, and I guess I should erase these up here. In order to do 192, I'm going to have to spend a 128. Okay, we'll borrow from the 9, we'll make that 8, and make this a 12. That leaves us 4 there and 6 here. So we still need 64. So let's spend a 64. Well, that's all we need. So the rest of these are all zeros. And so it turns out that 11000000 equals 192 in decimal. One thing I would encourage you to do, because you will find it very, very helpful later on, would be to memorize all of the possible consecutive ones. So in other words, like this: 1 0 0 0 0 0 0 0. You only need to do this for 8 bits. 2 ones, 3 ones, 4 ones, 5 ones, 6 ones, 7 ones, and 8 ones. Now, this will be helpful to you later on. You can always derive it, right? All you have to do is just recognize that you're jumping one at a time. I'm adding 128, then I'm adding 64, and then I'm adding 32, and so on. So this one is 128. The second one here with 2 ones is 192. The third one is 224. The fourth one is 240. The next one is 248, because I just added 8 more like that. And then the next one is 252. That's because I added 4 more. And then I'll add 2 more to get 254. And finally, I'll add 1 more to get 255. It really will be helpful to you if you can memorize all of these. And that way you'll be able to write them down very quickly later on when we need them, when we're doing a little bit more in-depth networking.